Hello guys, this is Elena from We Learn to Share, and in this video we're gonna cover the first question of the 2021 AP Statistics FRQ. So, moving on to the question, let's read the question. The length of stay in a hospital after receiving a particular treatment is of interest to the patient, the hospital, and insurance providers. Of particular interest are unusually short or long lengths of stay. A random sample of 50 patients who received the treatment was selected, and the length of stay and number of days was recorded for each patient. The results are summarized in the following table and are shown in the dot plot. The first question, determine the 5-number summary of the distribution of lengths of stay. I guess you guys will be all familiar with this 5-number summary thing because it's very frequent. It appears very frequently in statistics. So when you're doing the 5-number summary, there's 5 things to identify, right? You need to identify the minimum, the maximum, and the lower and upper quartile, and then the median. So we clearly see that the smallest number is 5, biggest number is 21. So that will respectively be the minimum and maximum. And then for the those quartiles, it needs to be up to 25%, 75%, and the middle. And remember that there are 50 patients in total. So having that said, I think that it will be easy for you guys to calculate those values. And so it will be 6, 7, and 8. Moving on. Consider the rules for identifying outliers, method A and method B. Let method A represent the 1.5 times IQR rule, and let method B represent the 2 standard deviation rule. Before moving on, let's just quickly review what these rules each stand for. So, actually, let's just deal with that in the 1, 2, those parts, okay? So, never mind. First, using method A, determine any data points that are potential outliers in the distribution of length of stay. Justify your answer. So, this 1.5 times IQR rule means that anything will be considered an outlier if it is smaller than Q1 minus 1.5 IQR. Or if it will also be considered as an outlier if it's larger than Q3 plus 1.5 IQR, right? And IQR equals the inner quartile range equals Q3 minus Q1, which will equal to 2 in this point. So this would be 3. And then we got this 6, 8, 3, right? So it means that this will be considered an outlier if it is smaller than 3, or if it is bigger than 11. So let's go and check. There's nothing more smaller than 3, but we do have something that is larger than 11, right? We have this, which is 12 and 21. So we're going to write that as our answers. Days are outliers. Next, the mean length of stay for sample is 7.42 days and there's a deviation of 2.37 days. Using method B, determine any data points that are potential outliers in the distribution of lengths of stay. Justify your answer. So, this 2 standard deviation rule identifies a number as an outlier if it is bigger than this is the mean plus 2 standard deviation, or if it is smaller than the mean minus 2 standard deviation. So let's just substitute these values into these equations. So this would be 7.42 plus 2 times 2.37, which will be equal to 12.16. So any number that is larger or bigger than this 12.16 would be considered as an outlier. Similar for this, which equals 2.68. Any number that is smaller than this would be considered as an outlier. So again, we do not have a number smaller than 2.68, but we do have a number that is larger than 12.16, which is, this is 12, so it will be over here, which is this 21 again. So you would say that 21 days is an outlier. The last question, explain why method A might identify more data points as potential outliers, right? More data points as a potential outliers than method B for distribution that is strongly skewed to the right. So if you say it's something that the distribution is skewed to the right, it will possibly look like this, right? And like the ultimate reason why method A would identify more data points as potential outliers than method B is because method A identifies outliers using medians, the RQRs, which means that it also considers like the upper quartile and like lower quartile, or like quartiles. Which are more robust or like resistant to skewness. This means that like it doesn't matter, even if your distribution is like normal or even is skewed to the left or the right, those like IQRs or like medians would have a higher possibility of not changing and not being like severely or like impactfully impacted by the skewness. But compared to that, method B, which is the 2 standard deviation rule, identifies outliers using the means and the standard deviation, right? I need to write this in full sentence, full words, but yeah, using means and standard deviations, which are less robust or less resistant, or like can say more influenced, like easily influenced by skewness. This means that if like the distribution is strongly skewed to the right, like in this case, then because means and standard deviations are very, very easy to be affected by this, there will be a higher possibility for them to have like a higher boundary, like higher upper boundary as a result, right? So therefore, the strong right skewness will cause the upper boundary or like the interval, like upper boundary to be like higher and the interval to be wider for method B, right? And therefore, this means that because like the interval and because the interval is wider, because the upper boundary is higher, you're going to capture more numbers. You're going to include more numbers in your interval. This means that there is a lower possibility for your wide interval to capture a outlier, right? And therefore, this is why method B will capture capture like more numbers, which means that it is harder to identify outliers. Or in other words, it means that method A, which uses robust medians, robust quartiles, robust interquartile ranges, they will identify more data points as potential outliers. Okay, so this is end of our video, and don't forget to press the like button and subscribe to our channel. See you at the next